We're moving on to Chapter 4, and we're going to be talking about factors, fractions, and exponents. We'll start off with our rules of divisibility and then have a short discussion on factors. We had a little preview of this in our last class when I put that list on the smartboard, and we're going to go over them in detail today. One number is divisible by another if the remainder is 0 when you divide. And I put together this chart, and hopefully it's in your notes, but we'll go over these. The rules of divisibility. An integer is divisible by 2 if it ends in 0, 2, 4, 6, or 8, which means it's divisible by 2 if it's an even number. Some common ones that you already know also include 5. A number is divisible by 5 if it ends in 0 or 5. 10 is another easy one to remember. If it ends in 0, it's divisible by 10. And then yesterday we talked briefly about numbers that are divisible by 3. We find out if they are by finding the sum of the digits, which means we'll take the digits. For example, if I had, let's say, 201. Well, 201, the sum of those digits would be 2 plus 0 plus 1, which is equal to 3. And 3 is divisible by 3, so the entire number is. What if I had 4,000, or we'll say 411. If I add up those digits, I have 4 plus 1 plus 1, which is 6. 6 is divisible by 3. It also means that 411 is divisible by 3. 9 has a similar rule. Find the sum of the digits and see if that's divisible by 9. And as some of you recall from our last brief discussion, a number is divisible by 6 if it's divisible by both 2 and 3. It has to be both, which means it's an even number and the digits added up are divisible by 3. And think about that. 2 times 3 is 6. And the last one we discussed was how we know if a number is divisible by 4. We can look at just the last 2 digits. So I might have 5,724. Well, the last 2 digits are 24. And if 24 is divisible by 4, which it is, that means that 5,724 is also divisible by 4. Let's do a little practice on this. We'll take it one thing at a time. Is the first number divisible by the second? Well, the way I'm going to use my rule of divisibility for 3 is I'm going to add up these digits, and that gives me 4 plus 2, which is 6. 6 is divisible by 3. It equals 2. So the answer to this is yes. Is 5,124 divisible by 4? Well, in that previous problem right above, I also had a number ending in 24, so this is a yes as well. We move on to the next row, and I have 1,629. So I need to add up these digits because I want to know if it's divisible by 9. So I'm going to have 7 plus 2 is 9, plus 9 is 18. 18 is divisible by 9. We have another divisibility rule check. The last one is 7,175 divisible by 10. Think about that for just a second, and your answer should be no, because this number does not end in 0. I'd now like you to take another look at this rule of divisibility by 6. Remember, it needs to be divisible by both 2 and 3. So is 162 divisible by 6? Well, it's an even number because it ends in 2, so that part checks. And then we look at the sum of the digits. 1 plus 6 plus 2 gives me 9, which it's divisible by 3. So yes, this is divisible by 6. I'd like you to create a table in your notes and put the following columns: divisible by 2, 3, 4, 5, 6, 9, and 10. And then going down in this first column, let's put the following numbers. Now you have two ways you can complete this table. You can do all the divisible by 2's first, or you can take one number and go across. Well, if we want to reinforce the rule, let's just take these and go right down the bottom. Now you could either put a Y for yes or a check mark to see if it works. Is this first one divisible by 2? Yes, it's an even number. The second one is also an even number. But 5 is not, but 4 is. 7 is not, whoops, and 0 is, and 5 is not. So the following column, we see that those numbers are divisible by 2. Let's go on to another easy one. Let's do divisible by 5. We'll come back to the others in a moment. Divisible by 5 if it ends in a 0 or 5. So let's put check marks everywhere we see an ending of 0 and 5. The other easy one on this would be divisible by 10. Check off the ones that end in 0. And now we're up to divisible by 3. Divisible by 3 says find the sum of the digits. So that leaves you to take 3 plus 0 plus 2, which is equal to 5. So it's not divisible by 3. 1 plus 0 plus 0 plus 2 gives me 3. Yes, it's divisible. Now, if it's divisible by 2 and 3, I can go right across and give it a check mark in 6. 4 plus 1 plus 5. That will give me 10, not divisible by 3. 5 plus 4 is 9. That's a yes. It's divisible by 2, divisible by 3, also divisible by 6. 1 plus 1 is 2. 2 plus 7 is 9. Divisible by 3. And guess what? That's also divisible by 9. 7 plus 2 is also 9. Divisible by 3 and 9. 235, that's 2 plus 3 plus 5, which gives me 10, not divisible by 3. Divisible by 4 says let's look at those last two digits. 20 is divisible by 4. 4 is divisible by 4. 20 is divisible by 4. And that's the end of the 4 column. We've already done the 6 and the 9. Oh, wait, yep, and that's our table. So I went down and completed the table by 2's, then by 3's, 4's, 5's, 6's, 9's, and 10's, just to reinforce the rules. Now let's talk about factors. Factors are numbers that multiply to give a product. One integer is a factor of another a non-zero integer if it divides that integer with a remainder of 0. So it goes back to our rules of divisibility. We can write this as a list. It says list the positive factors. Well, that's 1 times 10, and it's 2 times 5. There's my list. 1 times 5, 2 times 10. Those are the only factor pairs that it has. 24's list is a little longer. 1 times 24. It's divisible by 2. It's an even number. That's 2 times 12. From our facts or just from the rules, 2 plus 3 is 6. 6 is divisible by 3. That's 3 times 8. And lastly, we have 4 times 6. So I did say it was a longer list than the last. On to the next. 1 times 18. I have 2 times 9. And I have 3 times 6. So I can rely on my facts and I can rely on my rules of divisibility. 11 has only 2 factors, 1 in the number itself, because this is a prime number. We're going to be working on that in another section. 1 times 32. It's divisible by 2 times 16. Not 3, but it is divisible by 4, and that's 4 times 8. So there you have a little review of our listing of positive factors and our rules of divisibility.